Hi all, welcome back to Ugcnet. In the previous two videos, we have seen what's a left recursion, how we can eliminate left recursion from a given grammar, right? And we have also solved many examples on left recursion. And now in this video, let's learn about indirect left recursion. How we can identify whether the grammar contains an indirect left recursion and how to eliminate indirect left recursion. So if you haven't watched the previous two videos, please watch that video and then come back to this, okay? So what is left recursion? Left recursion means if the grammar contains any production of the form A produces A alpha bar beta, then we call that grammar as left recursive, right? So in order to eliminate left recursion, what we have to do? We have to convert that production into the form A produces beta A dash and A dash produces alpha A dash bar epsilon. Okay, so now let's check what is indirect left recursion. I will explain it with the help of an example. So let's consider one example. The question 1. So the question is A produces BA bar AA bar C and B produces BB bar AB bar D. So in these two productions, it is easy to find out the direct recursion, right? Direct left recursion. That means here you can see that the first production, the left hand side is capital A and the right hand side, the second term. This term starts with capital A. So obviously this production contains left recursion, right? Similarly in this second production, the left hand side is capital B and in the right hand side, this production starts with capital B. So this second production is also left recursive. I'm talking about direct left recursion. That means the left recursion that we have seen in the previous videos, right? Now what is indirect left recursion? Indirect left recursion means here let's consider A produces BA. Just consider that alone, okay? A produces BA. In that we can replace the variable B with its values. That means B produces BB bar AB bar D, right? So B is having three values. So instead of capital B, here in this production, instead of capital B, we can write it as A produces BA, right? So instead of B, we can write capital BB. So it is BBA. Similarly, we can substitute the value of B as AB, right? So AB and what comes A? ABA and the last term is D. So instead of B, we can write D also. But DA, right? So here in this production, A produces BA. We don't see any left recursion, right? But after replacing the value of B with these values, we can see that this term, the second term is containing left recursion. Clear? So that is why we call it indirect left recursion. In the first step, we don't see any left recursion, but after substituting the values, in the second step, we can see the left recursion. That is why we call it as indirect left recursion. Similarly, here in this second production, we already know that second production is left recursive because of this first term, right? But just have a look at the second term, that is B produces AB. Here, at first, we think that it is not left recursive because here the LHS is capital B and the RHS is capital A. So there is no left recursion. But in the second step, when we substitute the value of A with these three values, what it will become? It will become B produces AB. So instead of A, we can write BA. So it will become BAB. The second term is AA. So AAB and the third term is just C. So CB. So in the second step, this production B produces AB becomes B produces BAB, AAB and CB. So in this second step, it is clear that this production is left recursive because here in this first term, it starts with capital B and our LHS is also capital B. So it is left recursive. That is why we call it indirect left recursive. But please note that it is not compulsory or it is not necessary that both the production should be indirectly left recursive. It can be like the first production. It can be left recursive or it can be indirect left recursive or even it can be not left recursive at all. But the second production, it will be indirectly left recursive. Okay. So how we have to eliminate this indirect left recursion? For that, there are three steps. Step 1. In step 1, we will consider the first production and we will eliminate the direct left recursion from it. Please note, it is direct left recursion, not the indirect left recursion. Even if the first production contains indirect left recursion, we will just ignore the indirect left recursion and we will eliminate only the direct left recursion from that production. If the first production is not at all left recursive, we don't have to do anything. If it's left recursive, we have to eliminate the left recursion, I mean the direct left recursion from the first production. So our first production is A produces B A bar A bar C. So in this production, we have to eliminate only the normal left recursion. We don't have to mind about the indirect left recursion. So how we can eliminate left recursion from this production? This A produces, right? So we have to convert it to the form A produces beta A dash, right? So what's the values of beta? Here in this production, what are the values of alpha and beta? The left hand side is A, right? So in the right hand side, whatever terms that doesn't start with capital A is our beta, right? So this is beta. We can call it as beta 1 and this is also our beta. We can call it as beta 2. And in this middle term, it starts with capital A, right? So whatever comes after the capital A, that is our alpha. So this small letter A is our alpha. So how we have to convert it? We have to convert it to the form A produces beta A dash, right? Here we have two betas. So it is beta 1 A dash bar beta 2 A dash. Beta 1 is capital B A. So beta A dash. Beta 1 A dash bar. Second is beta 2 A dash. Beta 2 is C. So C A dash. And what's the values of A dash? A dash produces, it is alpha A dash bar epsilon, right? The value of alpha is just A. So A dash bar epsilon. So this is our first step. We have to eliminate the normal left recursion from our first production. And we converted the first production into these two productions, right? Now coming over to the second step. Step 2. Step 2 means we have to substitute the value of A in the second production. That means here the first production A produces BA bar AA bar C. That we have converted to two productions in the first step, right? Now we have to substitute the value of A in the second production. In the second production, this term AB, this term caused indirect recursion, right? So in that term, only in that term, please note only in that term. If A comes in any other terms, we don't have to mind that. We have to replace the value of A only in those terms which created indirect left recursion. So here in the second term, this A created indirect left recursion, right? So we have to replace this A with the newly created production. A produces BA A dash bar C A dash. Let me first write down the second production, that is B produces BB bar AB bar D. B produces BB bar AB bar D, and also the values of A and A dash, the newly created values A and A dash. The values are A produces BA A dash bar C A dash and A dash produces A dash bar epsilon. So in the first step, we have converted our A production to these two productions, right? And in this second step, we have to substitute this A with these values. Okay. So what will this production become? It becomes B produces, first term is BB. There we don't have to do anything. It is BB itself bar AB. In this AB, we have to substitute the values of A with BA A dash and C A dash. So AB, it becomes BA A dash B bar C A dash B bar. So AB, second term is finished. Now the third term is D. So we can simply write D. So now we have converted the indirect left recursion to normal left recursion. Here you can see this A created indirect left recursion, right? But now instead of A, we write these two terms, right? So here we can see that this term is creating normal left recursion. Here this term starts with B and the LHS is also B. So this term creates direct left recursion. So now in this B production, we eliminated the indirect left recursion. But please make a note that this B production is still left recursive. I mean the normal left recursion. So we have to eliminate left recursion from this B production, right? How we can eliminate left recursion from this? The format is, we have to convert it to the form B produces beta B dash and B dash produces alpha B dash bar epsilon. Okay. So here the values of beta are C A dash B is our beta 1 and D is our beta 2. Similarly, the value of alpha. Here small letter b is our alpha 1 and A dash B is our alpha 2. Right? Thus we can write this production as B produces beta B dash. Here we have two beta values. So beta 1 B dash bar beta 2 B dash. Beta 1 is C A dash B B dash bar beta 2 B dash. Beta 2 is D. So D B dash. And B dash is, the value is alpha B dash, right? Alpha B dash bar epsilon. Alpha means here we have alpha 1 and alpha 2. So alpha 1 B dash, alpha 2 B dash bar epsilon. Alpha 1 is B, B dash bar, alpha 2. Alpha 2 is A dash B. So A dash B dash bar, finally epsilon. So this is our final grammar. Now we can rewrite our final grammar. Here this A production is converted to two productions, and similarly B production is also converted to two productions, right? So the final answer, there will be four productions. Their first one is this one, A produces B A dash bar C A dash, and the second production is A dash produces A dash bar epsilon, and the third production is B produces, and the fourth production is B dash produces. So we converted those two production in the question into these final four productions. And now we can see that these four productions, all these four productions are free from normal left recursion as well as indirect left recursion. I hope it's clear. If not, you will understand it in this second example, the question 2. So the second question is X produces XSB bar SA bar B and S produces SB bar XA bar A. Okay. So in this first production, it's clear that it is left recursive because the RHS starts with capital X. So it is left recursive. Similarly, the second production, it is also left recursive because in both the sides, it is capital S. It starts with capital S, right? So it is left recursive. Both the productions are normal left recursive. Now let's check whether these productions are indirectly left recursive or not. Okay. So in the first production, X produces SA. If we substitute the value of S with this term XA, what it will become? It will become X produces XAA, right? XAA, right? So even though in the first production, this SA doesn't create any left recursion, after substituting the value of S with XA, it created left recursion, right? So we can say that the first production is indirectly left recursive. That means the first production is normal left recursive as well as it is indirectly left recursive. Similarly, in the second production, let's consider S produces XA. It is S produces XA. At first look, it looks like it is not left recursive, but after substituting the value of X with SA, what it will become? It will become SAA, right? Now it is left recursive, isn't it? So we can say that both the productions are normal left recursive as well as indirectly left recursive. How we can eliminate this indirect left recursion? For that we have three steps. First step is step 1. What is the step 1? We have to eliminate left recursion from the first production. So the first production is X produces XSB bar SA bar B. In this first step, we have to consider only the normal left recursion. We don't have to consider above the indirect left recursion. Okay. If in this first step, if the first production is not at all left recursive, we don't have to do anything. We can directly go to the second step. But here, we can see that this term created left recursion. So we have to eliminate left recursion from this production. So how can we convert this production? For that, first we have to find out the values of alpha and beta. Okay. So here we know that SA is beta 1 and B is our beta 2, right? And here whatever comes after X, that is SB, is our alpha. So there are two betas and one alpha. So how can we convert it? X produces What's the general form? X produces beta X dash. And here we have two betas. So X produces beta 1 X dash bar beta 2 X dash. Beta 1 is SA. SA X dash bar beta 2 X dash. Beta 2 is B. So B X dash. And X dash is alpha X dash bar epsilon. Alpha means SB. So SB X dash bar epsilon. So these are our first two production. This will be our first production and this will be our second production in the final result. Okay. Now coming over to the step 2. What is our step 2? Step 2 means we have to substitute the value of X from this first production. The value of X should be substituted here in this term. In this production, this step XA created indirect left recursion, right? Because S produces XA. So here, in case of X, if we give SA, it will become SAA. So it created indirect left recursion, right? So we have to eliminate this indirect left recursion and we have to convert it to normal left recursion. So what we have to do? We have to replace the value of X with SAX dash and BX dash. Okay. So the production S will become, S produces, first term is SB. We can write it as such. And second term is XA. In that XA, we have to give the two values SAX dash and what is there left? It is A bar BX dash A. BX dash A. And the third term is A. We can write the third term as it is. Now look here. It is clear that the indirect left recursion is eliminated from S production. And now we can see two terms that created direct left recursion here. Right? So what is the third step? Third step is to eliminate left recursion from this production. That means to eliminate the direct left recursion from this newly created S production. So for that, we have to find the values of alpha and beta, right? So what's the value of beta? This is our beta 1 and this is our beta 2. Similarly, this small b is our alpha 1 and AX dash A is our alpha 2, right? So how can we convert this S production? It will become S produces beta S dash. So beta 1 S dash bar beta 2 S dash. So it will become BX dash A S dash bar A S dash. And what's the value of S dash? S dash means alpha S dash. So here alpha 1 S dash, alpha 2 S dash bar epsilon. You have to write the epsilon at the end. Okay. So alpha 1 is B. So B S dash bar. Alpha 2 is A X dash A. So A X dash A S dash bar and finally epsilon. This will be the third production. This will be our fourth production. So these four productions, that will be our final answer. You have to write these four productions together at last. Okay. So this is our final answer. Let's consider one last question. Question number 3. So the question is S produces A bar B and A produces AC bar SD bar epsilon. Okay. So our first step, step 1 means, what is our step 1? We have to eliminate left recursion from the first production. That means we have to eliminate left recursion from the S production. But here it is clear that S produces AA bar B. In the right hand side, none of the terms start with capital S. So we can say that S production is not left recursive. So we don't have to eliminate left recursion from this production, right? So we can just skip the step 1. We can directly go to the step 2. What is our step 2? Step 2 means we have to substitute the value of S in our second production, right? Here our second production is A produces AC bar SD bar epsilon, right? So here we can see that it is directly left recursive because out of these three terms, one of the terms start with capital A. So it is directly left recursive. Now let's check whether it is indirectly left recursive. Okay. So here we can see that A produces SD. This production, it is not left recursive, but while we substitute the value of S with AA, here we can see that S produces AA bar B, right? So when we substitute the value of S with AA, it will become A produces AAD, right? Now we can see that this production becomes left recursive. So we can say that A produces SD is Not directly recursive, it is indirectly left recursive. So we have to eliminate the left recursion from that production. So what is our step 2? We have to substitute the value of S in this production. So this production will become A produces AC bar. In the second term, SD, we have to substitute the value of S with AA and B, right? So it will become AAD bar BD. And what is left here? It is epsilon. So epsilon. Now we can see that A production, A produces AC bar, AAD bar, BD bar, epsilon. This production has become directly left recursive. We have eliminated the indirect left recursion from that, right? Now coming over to the step 3, our last step, what we have to do? We have to eliminate left recursion from this A production. So first we have to find what is the values of beta and alpha. So in this production, out of these 4 terms, these 2 terms are our beta. They doesn't start with capital A. So this is our beta 1 and this is our beta 2. And what's the value of alpha? Here in this first term, whatever comes after A, that is our alpha 1. So C is our alpha 1 and AD is our alpha 2. So how can we convert this A production? We can convert it to A produces beta A dash. So beta, here there are 2 betas. So we can write it as BD A dash bar. It is epsilon A dash, right? Beta 2 is epsilon. So we can write it as epsilon A dash. But epsilon A dash means it is just A dash only, right? So we can just remove this epsilon from them. So A produces BD A dash bar A dash. And what's the value of A dash? A dash produces alpha A dash bar epsilon, right? So here we have alpha 1 and alpha 2. So alpha 1 A dash, it means C A dash bar alpha 2 A dash, that is A D A dash bar, finally the epsilon. Okay. So this is our final answer. So the first production, S produces AA bar B. In that we didn't change anything. So this is our first production. And the second production, A produces. That production we converted into 2 productions, right? So this is our second production and this is our third production. Okay. So I hope the indirect left recursion is clear now. In the next video, we will check about left factoring. Okay. So thank you for watching. See you in the next video. Bye.